In the next slide, we analyze just quickly for what we know at this point on the time and solvent use. Time needed will obviously vary. Time studies have shown so far that the DLW can provide equivalent wash effectiveness in 1 minute, whereas the other wash options, for instance, doing it with a syringe or even with the valve self-wash too, takes several minutes. And you see a depiction of some of these time comparisons on the slide. The total solvent consumption with the DLW varies, of course, because the pumps, they depend, the flow rate depends really on the fluids that we are handling and on some of the back pressure, loop size, loop length, and the total resistance that the pumps have to work against. But typically in the experiments that have been done, the consumption is 2.4 mil to 2.6 mil when using the DLW. Then some of the results that are presented here, a significant amount of test data has been generated by CTC and by their beta site. Some results are shown here for a UV and also for an LCMS system. CTC has used chlorhexidine and is the sticky compound that has been used for UV. And here are the conditions: 2 microliters of solvent, of sample has been injected, and the concentration is given here and the UV range. And these are some of the results, and bear in mind, there's a lot of data behind results. If any of you want more specific information, please let us know. But many other hardware manufacturers are using this concept, and that's why CTC has used kind of the same. A sample is injected and then is followed by 2 blanks, and you see the traces here in the diagram. Then the carryover result for the LCMS system, again, 2 microliter injection has been used. And by the way, these were loop overfills. There was a 2 microliter loop. Obviously, the injected volume was about 6 microliters. And here they used a cough suppressant. I should take that, by the way. My voice is not quite normal. And it's a known sticky compound. And I've seen in several other publications this being used as a good example. We want, obviously, to generate additional information together with some of our customers here in the U.S. And we're glad to work with some of you on sticky compounds that you are familiar with. The results are kind of summarized here in this slide. This is the MRM mode where you see the peak and the abundance, and then there is below is shown the blank in the scan mode, and that was the blank right after the injected sample. So if you have better ways of showing this or comparing, please don't hesitate to challenge us on that. I also want to mention that in the brochure that's available on our website, on the home page, you can download as a PDF. These same diagrams are shown in the conditions on the right-hand side. So if you need more time to study what it really means and what the conditions were, please do so. Then I want to mention that there are obviously always some other benefits of moving to the next generation electronics. It's important to recognize that the firmware software concept of the PAL needs to be credited for a solid, consistent, reliable performance of the PAL over the last 10 years. There has been no reason to change something that works, and something that works as good as the PAL. However, with new electronic components, CTC has been looking for improvements in connectivity. We have now Ethernet connectivity on the back of the PAL besides the RS-232 that remains. There is a memory improvement. Roughly, the memory is doubled. Better serviceability and power management. There's an external fuse that protects the board. And additional controls for new devices such as the DLW, which uses pump motors and additional solenoid valves. And there are certainly more new objects that I can imagine that are being created by CTC, and they will only be available on the new firmware 4.0. So it's a clear progress and step into the future with this new electronic board. There are other things mentioned on the slide here, faster movement. Just so you know, it's 10% or less on typical motions that we know from LC and GC inject cycles. Simultaneous motion of XY, if you have your arrangement of the objects optimized, you probably have already done a better job on cutting down travel time, and the speed of the individual XY motors are probably not contributing all that more to throughput. Then last but not least, I would talk about availability and pricing. Delivery from receipt of a PO, for instance today, would be about 6 weeks. Deliveries for POs that we receive on or after October 1 will get to a normal delivery time of about 2 to 3 weeks. And that's true for XT version PALs as well as for the upgrade kit. The price for the XT version on HTC and HTSs is roughly $1,500 to $2,000 more than the standard version. Now, when you consider that you're paying for an active wash and valve self-wash more than $1,500 or $2,000, we actually will offer the XT at a slightly lower cost, or let's call it about roughly at the same cost. Yeah, but you get more value for it. The upgrade kit without the installation is we kept under $5,000, $4,995. We hope with this XT versions and with the upgrade path that we're offering here to make a true contribution, and we hope to work with you on breathing some additional life to existing PALs as well as expanding with the XT versions in your lab.